Just to start with what we are going to cover, this is a study jam session, which is a series of sessions that which we do in collaboration with Google Cloud team. And in today's session particularly, we'll be covering aspects of cloud with Kubernetes Engine and GKE in specific order. What we're trying to do here is doing some hands-on sessions on some of the deployment tools that we'll be covering, and how do you set up those clusters on Kubernetes, how do you use these deployment tools on GKE, right? A short intro to the speakers. As I mentioned, I'm the lead cloud consultant at Searce. My primary focus region is Southeast Asia. I work with digital native and enterprise customers across Southeast Asia, predominantly in Malaysia, Singapore, and Indonesia. I have in call with me Alfred Tommy, who is a part of our CS team. Alfred is a lead cloud architect. He is active in a lot of activities where we are helping customers with solutioning, helping customers with understanding GCP solutions when they're just trying to move to GCP. Yongwon is the partner engineer, and we work very closely with her for a lot of customer opportunities, as well as our internal upskilling on the Google Cloud side. Just to touch upon the agenda, right? I'll just spend, let's say, 2 minutes in explaining to you how Searce comes into the picture, what is Searce, how we are working with Google Cloud within the cloud ecosystem. Then we'll move to the introduction agenda to Google Kubernetes Engine. Yongwon will take care of that. She'll explain to you how Google Kubernetes Engine works, what are the special features, what are the differentiating features in the GKE. Then we'll move on to a hands-on session where we'll be covering setting up the clusters on GKE. We'll cover a deployment tool, which is kubectl, which Alfred would be taking you through. And towards the end of the session, we'll open it up for Q&A. And there's a short quiz, which would be an interesting game that Alfred would lead. At any point in time during the session, if you have any question, feel free to drop them on the chat room. What I'll do is I'll pick those questions and redirect them to the speakers, and they can answer right away, so that we keep the session interactive, right? So don't hesitate in asking the questions during the sessions as well. If there are some that are missed, we'll take them towards the end of this session. Just to give you a snapshot about the company, Searce has been in existence for over 14 years. We are a cloud-native company that focuses on AI, ML, and cloud-led business transformation. Our key expertise or focus is on cloud adoption and cloud optimization. So both for the traditional customers who are just trying to explore cloud, we help them with the cloud adoption. And with digital native businesses, we help them, let's say, map the modern day GCP services that can help their business, right? And further optimize and modernize their infrastructure so that they can scale up when they grow and start to become unicorns of the today's world, right? Over these years, we have worked with a lot of customers, more than 3,000 of them, which means that we have an expertise of working with customers, because these customers came from different industry verticals, right? So be it any industry vertical, we have catered to customers and helped them on Google Cloud services across the industries and across the verticals. In terms of global presence, we have global presence in the APAC region. So in the APAC region, we predominantly operate in Southeast Asia, North Asia, and India. We have operations in North America, and EMEA is one of the recent regions that we started operating in. Last couple of years, we've been focusing in EMEA, and we have offices in Europe as well. In terms of our strength, we are 600 plus improvers, we call them. Out of these, more than 300 of this team is from the tech side, who focuses on the cloud engineering, data engineering, and infrastructure side of things. A lot of these people, more than 200 of these people, are associated and professional level certified, which means they have certification across cloud, not just Google Cloud, but they have expertise on different cloud verticals. So when we have these discussions with different customers, with different developer groups, we understand the whole context of the overall cloud ecosystem, and then we can advise on the next steps. Just a quick show of how we are working in the Southeast Asia region specifically. So we have been working with all these customers in the region. If you look at this, a lot of customers would be very familiar to you, including, let's say, Air Asia Group, Happy Fresh is one of them, ZepPay, Commonwealth Capital, Crystal. These are all digital native businesses and a mix of traditional and enterprise businesses as well. what is worth noticing is a lot of them are also unicorns, which means that we like working with digital native businesses and help them grow to become the unicorns that they have been aiming for, right? Now, I'll just hand over the session to Yongwon. She'll probably cover the introduction to GKE, how it works, what are the differentiating services and factors in the GKE services. Yongwon, over to you.
Yep, thanks, Sarang. I will share the slide from my side.
Sure.
Yep. So hi everyone, I'm Yongwon from Google Cloud. I'm the partner engineer based in Singapore covering Southeast Asia. And I'm excited to share an introduction to Google Kubernetes Engine today. So we'll spend about 10 to 15 minutes to give you some context before we go into the lab. So I will start with a quick recap on what is container, and also I'll move to the GKE part. As you know, Kubernetes is an open source solution, so we have other vendors providing Kubernetes. But here I will spend some time to introduce how Google Kubernetes is different and why it's better than other vendor solutions. And at the end, we have two different models for operations. So I will also introduce these two options that you can choose from. So let me start with the container itself. I'll just have a quick recap of how the computing started. So a long time back, when people first started to use the computing, we started with the bare metal, where the whole application stack was tied to a single hardware. And based on that, we saw a lot of resources are not fully utilized. And to improve that, we came to the second solution called virtual machine. As you know, in the virtual machine environment, we virtualize the hardware so we can host multiple VMs in one single server. So by having this smaller set, we saw a lot of benefit, and people wanted to make it even smaller. So the newest version we have is container, as you see now. So instead of virtualizing hardware, we're virtualizing operating system. So we can have multiple container in single OS kernel. And container itself is a lot smaller than virtual machine. So it's a lot more lightweight, it's portable, and it's faster. And with this change, actually, there is another change in the whole application architecture. So in the VM world, we used to have 3-tier, 4-tier application that was relatively easier to manage. But those 3-tier, 4-tier app is now moving to hundreds or thousands of microservice containers. And managing this bunch of containers can be very complex. You need to set some scheme to assign the resources. So you need a resource manager, you need a job scheduler, and you might need some scheme to network these different containers. So to have this whole orchestration and management problem solved, now we have Kubernetes. So Kubernetes is the container orchestration tool in an automated manner. So in other words, what Kubernetes provides is that it gives you the environment to run the container in a stable manner with a lot of tool sets that you can leverage. And it provides abstraction over infrastructure. So you can host the container in your infrastructure easily. And also it provides a set of declarative APIs for you to connect these different containers and also consume the containers more easily through API. So in this whole picture, we have containers, and Kubernetes is the orchestration tool to manage those containers. And then let's move to the Google Kubernetes Engine part. So the concept of container actually came out a lot earlier than you think. So a long time back, over 15 years back, the first concept of Linux container came out, and Google saw the value of containers since then. So we started to deploy container for our internal usage. So we developed Kubernetes for our internal consumption actually, but we saw a lot of value and we wanted to contribute and share with others. So we open sourced it in 2014. So Kubernetes itself is open source, so anyone can use it. But people actually wanted to have some managed service so they can consume it easier. So in 2015, we launched Google Kubernetes Engine. So this is a Kubernetes engine that is hosted in Google Cloud for you to consume it as a cloud service. And we also saw a lot of customers want to have a multi-cloud environment. They have on-prem and other cloud connection as well. So we recently launched GKE on-prem, and we also provide GKE on AWS. So you can also run GKE in different forms as well. So as I said, Kubernetes is open source. Anyone can use it. So, and a lot of vendors has been contributed to the development of the Kubernetes environment. But still, Google is remaining as the biggest contributor in the Kubernetes. Because we are far ahead than others in terms of experience. We've been using containers for our own services. So we use containers for our YouTube, Gmail, Google Search, and other things. So we have rich experience of us running our own sets. And also in GKE itself, we usually launch 4 billion new containers every week. So we have the richest experience in the market. So we can pretty much say that even though Kubernetes was open source, it was actually built and distributed from GKE itself because we are the biggest contributor. And based on that, we added a lot of innovation on Google Kubernetes Engine. And our customer actually see the benefit of those innovations, which is why they are choosing Google Kubernetes Engine from other form of Kubernetes. So I'd like to introduce you a bit deeper on each of the topics. So firstly, it's a lot bigger scalable, and it's a lot easier to use. You can spin up much faster. And it's enterprise ready, which is very important if you want to use it for production. And also it's multi-cloud ready. So the multi-cloud part, I already shared that we have GKE on-prem and GKE for AWS. And if you want to build a real multi-cloud experience, you can have another solution called Anthos to have to build a whole multi-cloud stack. So before we go there, let's take a look at on each of the steps one by one. First, let me talk about the scalability. What I mean by scalability is that previously I mentioned that in Kubernetes, we build a cluster of the containers and manage them at once. So there's a size of the cluster that one control plane can manage. So in the market, the biggest cluster size besides Google that's provided is having 3,000 nodes in one cluster. But in Google, so the biggest one is 3,000 besides Google. But if you see the number, what Google can provide, we can have 15,000 nodes in one single cluster. So we are not saying we are 20% better or twice better. We are talking about we are 5 times better, bigger, and 15 times bigger than other vendors. This is a good example of how advanced we are in terms of container management. Even though Kubernetes is open source, we need some sort of experience and expertise to scale the Kubernetes management. And yeah, Google has the biggest experience. So as you can see here, the features and scalability is not comparable. And it's not only bigger, and also it's easier to scale. So in the cluster, we have clusters and single nodes. And in the nodes, we have something called pod, which is a set of the containers. And we provide the pod auto scaling. So we keep monitoring the resource utilization of the pod, and we adjust the CPU and RAM to stabilize the workloads. And not only the single node level, we also see the bigger cluster level auto provisioning as well. So we keep adding nodes and removing the nodes to adjust and optimize the cluster size based on your consumption. So our scalability is far better than others. And also it's a lot easier to manage them because we support auto scaling. And it's also very easy to spin up the new cluster. Kubernetes is a very powerful solution, but at the same time, it's pretty complex to spin up. So a lot of people has misconfiguration when they want to do it by themselves. But if you're running it on Google Kubernetes Engine, you can guarantee that everything is all set. You can simply click and put a little configuration to spin up the new cluster in a very short time. So it's very easy to start. And once you start it, all the management day 2 operation is built in Google Cloud Console. So you can use it as your virtual machine instances in the same console with Google Cloud. Another thing I want to emphasize is that we are enterprise ready. So no matter how Kubernetes is scalable or it's easy to use, if it's not reliable, if it's not scalable, you can never use it for production. But Google Cloud, we provide the enterprise level scalability and reliability. So we have our site reliability engineers to make sure that all the services you're hosting on Google Cloud is stable and reliable. So all the application you're providing to your customer will be reliable with certain SLA. And also, if you have a global footprint, it's easier to have a cluster in the multi-zone or multi-regional level to make it even better to use. And also there are other features that we support for enterprises, which is important, like resource limitation. For example, this can be important for your budgeting. And for the application, we provide stateful application support and security and compliances that you might have to meet to run the enterprise application on GCP. And we also invest a lot on our developer experience. So to make sure that whatever value you want to bring to the customers, you can develop it faster and implement it even faster to bring it faster to your customers. So that was all the benefit we've seen so far. It's a lot scalable than others. It's very easy to use. We are enterprise ready with very reliable SLA, and also we are multi-cloud ready as well. So let's move to the last part, which is our operation models. So as I said, Kubernetes is open source. So you can actually buy any server and spin up the Kubernetes. So you can do DIY Kubernetes service, which you need a lot of configuration. And actually, when you're spinning up and do the day-to operation, there's many room for misconfiguration because it's a complex solution. So for customers to use it more easily, we are providing Google Kubernetes Engine, as I said, Kubernetes in Google Cloud. So with a very minimum configuration like security or network configuration, you can start to use Kubernetes and containers a lot easier. So we launched this in 2015. And ever since that, based on our expertise and innovation, we've been adding a lot of new features in the GKE itself. But we still hear a lot from the customer that, especially if they're moving from VM to the container for the first time, they always ask, so what's the best practice to run this? What's the best way to configure that? So they wanted to have some even easier experience to run containers, which is why we launched this new version called GKE Autopilot. So as you can see from the name, managing the Google Kubernetes Engine is very much automated, so you can have a hands-on experience of running GKE. So what it has inside is that based on our best practices that we tested and hardened in the past 6-7 years, everything is pre-configured, so you can simply use and make sure that it's best practice that is optimized. And also you can optimize the workload. Based on the workload type, we will dynamically assign the resource to make sure that this is optimized. And also, everything is pretty automated. So even though you haven't had much experience with Kubernetes, with a minimum learning curve, you can start to use Kubernetes very easily. And in terms of cost and management, we keep doing the dynamic resource optimization and also optimize scaling to make sure that none of the resources are wasted to adjust the size based on your requirement. And also we do pay per pod, so there won't be any standby cost. So you just like pay as you consume, which will save a lot of cost for you. So those are the two modes that I wanted to introduce. We have GKE standard mode that will that will give you some room to still adjust and configure some of the feature. Or if you want to fully automate, we can also have autopilot mode, in which everything is automated based on our best practices. So this autopilot is very recently launched. So this is the newest innovation we added on our GKE environment. So now it's your time to bring all our innovation and bring it to your company to leverage and benefit from those innovation. And as the first step, let's start the lab with Alfred. Thank you. And if you have any question, you can leave it in the chat, and I will hand it over to Alfred for the lab.
Thanks, Young. So good morning, everyone. Thanks for the comprehensive overview of GKE from Young. I hope you guys have a good theoretical understanding of what Kubernetes is and the kind of benefits GKE provides. But that being said, let me share my screen just a second. I believe now it's time for the lab, the hands-on session, right? So this is where we're going to get down to the ground level and actually work with GKE. So let's just cover what we're going to, let's just go through what we're going to cover in the session, right? So it's going to be, the lab itself will be an hour and 15 minutes. This is a lab which I have done in the past. Given a beginner level of understanding, it should take you an hour to complete. But that being said, it's okay to extend a bit. I will also want to keep the session a bit interactive. So in the middle of the session, if you have any doubts, questions, or queries, please feel free to write it down in the chat window, and one of my colleagues will relay the question over to me. So we're going to cover the deployment of an application called app, for lack of any creativity. And we're going to try deploying it in two kind of modes, right? We're going to deploy it first as a monolith, and then we're going to actually chunk it down into its individual microservices and deploy it as a microservice-based architecture on GKE. I'll also show you how to work with the basic Kubernetes resources, pods, deployments, and services, right? These are the main ones. And we'll also touch upon config maps a bit, but we won't delve too deep into that. Okay, let's move on to the actual Quick Lab. I'm sure most of you must already be familiar with the process of signing into the Quick Lab. You must have received an email about that. So the first thing you want to do is follow along with me, right? You want to open the link that's given here. So this should take you to the study jam, Orchestrating the Cloud with Kubernetes. Everyone, please follow along with me, okay? We're not going to start the lab just yet. I want to just cover a bit of the theory before we get into the actual lab itself. So as it's mentioned here, right, the application we're going to be working with is called app. We'll be pulling the source code from a public repository. And we have basically 4 images we're going to be working with, right? So first is the monolith image. And the monolith basically consists of, excuse me a second, let me just keep it on charge. And the monolith essentially consists of 2 services, a hello service and an authentication service. The purpose of the hello service is to return a hello text message to authenticated users. And the auth service is meant to generate and provide a JWT token to the users for them to authenticate. Nothing too complicated, believe me. And then we have the individual microservices containerized. So we have the auth and hello microservices as individual microservices. And of course, we have an Nginx web server container to actually give a front end to this application, right? Because we need to have some kind of UI to see how things are going. So with that being said, let's start the lab. So please follow along very closely. I'm starting the lab, post which they're going to ask me to verify that I'm not a bot. And here I will be asked to enter a lab access code. This is where you guys want to use the code that was provided to you. So you're going to take 4 digits at a time. So let's take the first 4 digits for me. This is my access code. It's my unique access code. You guys will have your own access codes shared over the email. And with that done, I should be able to access the lab. Great. Okay, so you can see the lab is started and the timer is counting down now. No pressure. We have plenty of time. I'll try to cover things as methodically as possible. Okay. So now you see we've received some credentials on the left-hand side of the screen. What you want to do is you want to open Google Console, but you do not want to open it directly in a new tab because it's just going to use your same account. So what you want to do is you want to open this link in an incognito window. And this is what we will be using essentially. When they ask you for your username, you're going to pluck up this username from here, copy it, and paste it here. And likewise, we're going to follow the same process for the password, which is also provided here. Accept the TOS. I believe there'll be one more TOS I have to accept. Yep, there you go. That's the last TOS. Agree. And ta-da! I now have access to a Google Cloud Console project, right? And this is, I essentially have full access into this project. I can do pretty much anything I want, but I'm going to follow along with the lab. So once you have access to the screen, right, once you open up this console screen, just look at the top right corner of the screen. You will see an Activate Cloud Shell button, right? I want everyone to just go ahead and click on this button. And what this does is it's going to spin up a micro virtual machine for us to actually have a CLI interface to interact with Google Cloud APIs. And in terms of permissions that this machine has, we will be authorizing this machine. So any permission that I as a user have, which is owner permissions essentially, will get passed on to this machine. And this is the machine that I will be using for this project, right? But what I want to do is let me open this up in a new window so it's easier for everyone to see. So you can just click on this button here on the right side, the rightmost side. It'll say open a new window, and this allows us to open the shell in a new window. And it's just like a normal Debian machine. Excuse me. Okay. So now that we have our shell set up, we have our console access. First thing we want to do is we want to get the source code. Okay. But I think before that, let's create the cluster, right? So the cluster, the Kubernetes Engine cluster that we are going to be creating, it's going to take around 5 minutes or so to provision. So let's get that done with pretty quickly, right? So the first command you want to run is you go to the Google Kubernetes Engine section. You can skip out everything else. Once you reach the GKE section, the first thing you see they're doing is we're setting a default zone. So right now we're choosing US Central as the zone for our operations. This just means that whatever cluster we create is going to default to this particular zone if we do not specify a zone of our own, right? And then go ahead and so in this particular lab, the zone doesn't really matter, but let's just keep it in US Central for the sake of this session. And post that, we are going to run the create cluster command, right? So this command, gcloud container clusters create IO. So we're creating a cluster called IO, and we're not passing any flags or options. So it's going to pick up all of the default settings. Now I need to emphasize here that this is not how you create a production cluster. This is purely for the sake of our lab purposes. We want a simple and quick and easy to deploy cluster. So for our purposes, this will work perfectly fine. But in a production environment, obviously, you want to add the additional security parameters and whatnot. I recommend you get this command running as soon as possible, the create cluster command, because this process might take some time and you don't want to be lagging behind, right? So what have we done so far? We've set the zone and we're creating the cluster. While the clusters are being created, we're going to get the sample code. Okay. So the next thing that we're going to do is we're going to get the source code repository where all our application code is actually held. So while the cluster is creating, right? So let's take a look at our console environment and see what's going on. Let me just close this. Yeah. So I've run the console. I've run the cluster creation command. If I go to Compute Engine, what I'll observe here is that as a result of that command, I can see GKE nodes being spun up and configured. As soon as this page loads up, you will see that yourself. So here you can see, like I have. Let's hide this. So you can see I have 3 nodes created in my cluster. They are all in the zone which I had configured earlier, which is US Central 1B. And they all have their own public IPs, they have their own private IPs, and we can see that they are in use by the Kubernetes instance group, okay? If I navigate to my hamburger stack and I go down to Kubernetes Engine here, which is just below Compute Engine, I can actually see the cluster itself. So here's the cluster IO. You can see it's still creating. If I click on this, it'll show me the progress of creation. So it should be in the health check stage, and it is. So 83% of the cluster is completed, which is waiting for the health checks to be configured and passed successfully. Post which we will have a working cluster to interact with. Do make sure you are following along, because I think there are certain steps which are lacking in the quick lab itself. But we will, if you're following along, you won't have any issues. And there we go. So now we have the tick mark here. We know our cluster is ready to go. Once you have your cluster set up and ready, right? What you want to do is you want to click on these 3 buttons here, and you want to click on this connect option here, right?
Alfred, sorry to stop you, but I noticed in the chat room that a few people are still struggling with the code. Is it possible we wait for a couple of minutes and then we can resume?
Oh, people are still stuck with the code. Can you tell me how many people are stuck with the code?
Yeah, I see quite a few, around 5-6 people who are still getting some errors in the code. So probably a couple of minutes before they can just log in.
I see. Well, the thing is, I've already started the lab. The
Oh, okay.
timer is running down. If it's just 5 to 6 people, I suggest you try to help them out offline. But I don't think. See, if I wait right now, it might impede the other attendees.
Okay.
But at the same time, I don't want anyone to miss out on the lab. So perhaps the right way to go about this is please, in an ad hoc offline mode, try to help them out as much as possible, get their link working and stuff.
Sure.
And that responsibility is on you and Megha to get their links set up and ready. In the meantime, everyone whose links are not working, I do suggest you still pay attention to the theory aspects that we are covering, right?
Sure.
Even if you're not able to access the lab yet, at least leave the session with an understanding of the theory. It's going to help you a lot in the future, believe me. But that being said, Sarang and Megha, please help them out as soon as possible. Okay.
Yeah. I'll paste the steps as well again in the chat room, so anyone who has missed the initial phase can refer to them. Okay,
yeah,
you can continue.
Whatever means you see fit. Okay.
Yep.
So now we have our. I'll apologize to the users who haven't been able to access, but we will be proceeding with the session. So once your cluster is created, right, you will have your tick mark here. As I mentioned, you want to click on these 3 dots, and you want to click on the connect option. Okay, and once I click on these 3 dots and click on connect, it gives me a command, a CLI command. And I'm just going to copy this command. And if anyone has worked on an unmanaged Kubernetes environment, this is the equivalent of passing your bootstrap credentials into the kube config. So basically, this generates a kube config entry for you. In layman's term, this authenticates you to the cluster. Without this command, I will not be able to run any kubectl operations on my cluster because I would not have been authenticated with it. But now you can see a kube config entry has been generated for me as a user, and I have authenticated to the cluster. So now I can basically utilize the cluster to run my kubectl command. So if I just do kubectl get nodes, I should now get a response. And there we go. The Kubernetes API is responding to me and telling me we have 3 nodes in our cluster. These are the 3 respective nodes. Okay. So once we've connected to the cluster, let's work on actually deploying our applications itself. But before that, let's get the source code for the applications, right? So we're going to be pulling from a public repository, and this repository has everything, right? It has our actual application source code. It doesn't have it doesn't have the application packages and stuff, but it has all the YAML manifest. So we interact with Kubernetes using these Kubernetes resources, pods, deployments, services, etc. These are all created in the form of YAML files, and all these YAML objects and files that we will be using are all in this repository, including our SSL certificates, our config maps. Everything is in this repository. So definitely make sure you run this command and you copy this repository. We will not be able to proceed without this. And this command itself is basically running gsutilcp. This is we're pulling data from a public GCS bucket. And for those of you who do not know what GCS is, it's Google Cloud Storage. It's a blob storage bucket similar to AWS S3. And once we've pulled the repository, we're going to go to the directory, orchestrate with Kubernetes/Kubernetes. And you can see I have my files here. I have my deployment files in this folder. I have my Nginx configurations in this folder. I have my pod YAMLs in this folder. I have my service YAMLs in this folder. And I have my certificates, my SSL certificates in the final folder. So now that we have our source code ready, let's tinker around a bit with Kubernetes itself, right? So let's go through a quick Kubernetes demo. So we're going to run this command, kubectl create deployment Nginx -- image equals to Nginx. So what I'm doing here is basically this command. It's creating a pod. It's creating a deployment, and we'll cover what pods, deployments, and services are in a bit. But for now, you can consider that we're creating an Nginx container of sorts, okay? And we're passing on the image name via this flag. This image is not a private image, it's a public image. So we're pulling it from a public repository, which is why I've not been asked to authenticate or anything, or authorize or anything like that. So you can see that it's been created pretty quickly. And now if I do kubectl get deployment, I can see my Nginx deployment is here. And if I do kubectl get pods, I can see my Nginx pod is here. And you can see that this deployment has 1 pod running. The next thing we're going to do is just for tinkering around with Kubernetes itself, we're going to expose the service. So as of now, I have an Nginx container, but how do I access this Nginx container? Say I want to access this container over port 80, right? Because this pod is deployed within the cluster, it's only accessible within the cluster, right? But so to make it accessible outside the cluster or to other services, what I need to do is I need to expose it. And how do I expose it? I expose it using services, right? So what I'm doing here with this command, kubectl expose deployment, I'm basically saying to expose this deployment over port 80 using a type load balancer. So this is going to create a load balancer for me. And the load balancer is going to direct traffic to my Nginx backend. So if I do kubectl get services or get svc, I can see that a service has been created of type load balancer for my Nginx application. And you can see here an external IP is being provisioned for this, right? Because it's of type load balancer, it needs a public IP. So that public IP is going to get provisioned in a bit. So let's run it again, and we should have our add a -w for watch command. So this -w is just watch, it gives you, yeah. So now we have the updated value. And you can see that we have our external IP. So after waiting a bit, you yourself will get, after waiting a while, you will get an external IP for your load balancer. Copy this value onto your browser. What can we expect? We should see the Nginx homepage, right? So previously the pod was not accessible outside the cluster, but by exposing it via this load balancer, I can access it from my own browser. So now let's move on with the actual quick lab, right? This was just a quick intro into Kubernetes, how to deploy pods and services. We're going to go into our actual line of work now. Click on the check my progress bar. You should get the tick mark. I'm going to wait a bit for people to catch up. But at this stage, you should have your Kubernetes cluster deployed. Ideally, you should have your Nginx deployment deployed, your Nginx image. And ideally, you should have exposed it via load balancer. And finally, you should validate the load balancer by curling the endpoint. The IP might take some time to provision. Don't worry, it eventually will. And then once it does, you will be able to access it from your browser. Okay, now that we're done with the quick intro to Kubernetes, let's go into the actual things we'll be doing, right? So we will be working essentially with 4 kinds of Kubernetes resources: pods, deployments, services, and config maps, okay? We will also be working with secrets, but we'll get to that in a bit later. So at the core of Kubernetes is the pod. So the smallest deployable unit in Kubernetes is a pod. Now, what is a pod actually? A pod is a logical container of containers, right? That's one way to put it. So it's a container for containers. And you can have multiple containers within your pod. You can have 1 container within your pod. You can have 2 containers within your pod. You can have 3 containers in your pod if you'd like. But generally, what you normally see in real life scenarios is oftentimes you'll find most pods have 1 container or 2 containers. The second container could be a sidecar container or something like that. But generally, you'll have 1 or 2 containers per pod. In my line of work so far, I have yet to see a pod with 3 containers, but it's not, it is technically feasible to have that as well. And like I said, it's a logical grouping of 1 or more containers. And the containers within a pod, they share the same host resources. They share the same namespaces, but they have different virtual IPs allocated to each pod. Right? So they share a lot of the same, they share the same networking resources, any resources they take from the host. They also have the option of sharing the same attached disk, right? Both the containers within a pod can share the same disk volume. They can also use different volumes, but that option is there, right? So it's very flexible what you can actually do with the pod. And each pod has its own unique IP address. It's not a physical IP address. It's a virtual IP address, which is actually used for IP table routing and things like that. We don't need to get into that, okay? So let's start with our monolith application. If you remember our monolith application, it consists of the hello microservice and the auth microservice. Right now, it's not split into microservices, so it's a monolith, right? Let's look at the monolith.yaml. Let's close this. So I am in my pods directory /monolith.yaml, this is my YAML file for my pod deployment. Here you can see, so the most one of the most important parts here is the actual specification of the pod. And here you can see, I want my container to have this name, the name monolith. I want my container to have this image. I want my these arguments to be passed on to my container. What port is the container going to be listening on? It's an Nginx web server application, right? So naturally, it's going to be listening on the default port 80, which is why I'm exposing this container via port 80. I'm telling it to listen on port 80. And I've also set another port 81 to listen on. This is primarily for health check. This is not for the actual serving of user traffic, but just for health check, you can use a different port. So you can expose multiple ports on a container. And finally, I'm defining the resource limits here. So here I can say that I want my pod at a maximum, right, at its peak to consume 0.2 vCPU or 200 milli CPU and 10 megabytes of memory. If it consumes more than this amount, the pod will get throttled or evicted based on what it's over-consuming. So I'm just defining all of these things in my pod.yaml, okay? So let's go ahead and create this. If I apply this, so you can create this, you can actually create this pod by running kubectl, and everything we're going to do is pretty much via kubectl, right? That's our Kubernetes command line tool. So we're going to do kubectl create -f, and we're going to point it to our monolith.yaml file. And what it's going to do, it's going to look at this YAML, it's going to deploy this pod with this image over with these ports. So let's go ahead and create it. And it gets created very quickly. And if I do kubectl get pods, I can see that my monolith pod is there. A very useful command, especially for people who are new to Kubernetes, is the describe command. So if I do kubectl describe pod monolith, right? So I'm doing kubectl describe followed by the resource type. So the resource type is either pod or deployment or services. Here I'm choosing pod. Kubectl describe pod monolith. Once I run this command, monolith is the name of the pod here, right? So once I run this command, I can see a bunch of data about my pod, right? I can see my name, the name of the pod, which namespace it's deployed in, what IP it has. This is the virtual IP it has, the actual container IDs. A lot of information is there. But perhaps one of the most useful information here are the events, especially when you're debugging or troubleshooting, right? This is one of the first places to go to, right? After checking the logs, you want to see the events here. And here you can see, like, if it has any trouble pulling images or if there are any errors within the pods, within the pod that, that caused it to not be able to schedule, it's very likely you're going to see those error messages over here. So this is a very good way to actually debug and troubleshoot, right? By using the describe command. And just like we did describe for the pod, right? Like I said, we can do it for all Kubernetes resources. So if I do describe on the Nginx service, so I can do kubectl describe service Nginx. And here I can see I'm getting details about my Nginx as well, right? I can see it's ensuring the load balance, it's getting the public IP, things like that. It's a very useful command. You can use it for, like I said, all Kubernetes services. Now let's interact with the pod, okay? So this pod, this monolith pod that we have, right now we do not have any service. So remember, for the Nginx, we created a load balancer, right? Right now there is no service for this monolith, meaning we are not able to access this. It cannot be accessed outside the cluster. So there are two ways I can actually access this. One option, there are three ways actually. So the basic option is to expose it, via service, load balancer, or a node port, or let's just say a service for now, okay? The second option is that I can log into this pod and then curl my local host. Not an ideal option, but I can do that. And the third option is I can do port forwarding. And this is purely meant for, testing purposes, for local testing. So I'm going to run this command, kubectl port forward, pod name, local port, container port. And, oh, sorry, let me close this. So what you want to do is, before you run this command, you want to click on this plus button, and click on the plus button again. And what this does is it creates a new tab. It creates a new terminal. So we have two fresh terminals to work with. The reason we're creating a new terminal is because this port forward command, it's going to kick us out of the interactive state. So if I run this port forward command, I can no longer interact with this terminal, right, while it's doing the port forwarding, which is why I'm going to go back to my first terminal. Now, the port forward command, what it's doing is it's telling Kubernetes that whatever traffic is going to my container, my monolith container over port 80 should be forwarded to my localhost over port 10,080, which means that now, technically, if I curl my localhost, which is 127.0.0.1, over port 1080, I should be able to access the monolith application. And there you go, I'm getting the hello response from the monolith application. How did I do that? By forwarding the port to my local host. Now let's try, so this was a very generic way to curl that endpoint, right? But what if we curl it with a /secure? So this /secure endpoint requires us to authenticate, right? Remember the authentication service. What is the purpose of the authentication microservice? The purpose is to provide a JWT token. Without that JWT token, what kind of response are you going to get? You're going to get authorization failed, which is expected, right? We didn't authenticate. So now let's try logging in to get an auth token back from the monolith. So we're going to run this command, and this command is actually going to ask us to enter a password. So we entered as this user U, and the password, by the way, is password. So PASSWORD, very secure, right? They mentioned it here as well, I believe. Yeah, super secret password, right? So you run this command, and they ask you for your password, and you enter your password, and as a result of entering the right credentials, you get a token ID. This is what we're going to use to authenticate our request. So we're going to authenticate our /secure request with this token, and that should authorize us. Now, since copying long strings is not ideal on the Cloud Shell, what we're going to do is we're going to do this essentially the same thing. The only difference is that we're running this command, token equals to curl blah blah blah. The reason we're running this is because we want to get our token value, this entire string. We want it in this bash variable called token, just to make our lives easier. So if I do echo $token, I now have my JWT token in this variable. So now let's try sending another curl request, but this time let's authorize it with our JWT token. Let's see what response we get. So we're doing the same thing, right? So, oops, sorry. So now we're running the same thing. The only difference now is we're curling and we're mentioning that after the bearer section, we're mentioning that this is our token for authorization. And post this, so previously we were getting authorization failed. Now that we are providing the right credentials, we should see the successful response. What is the expected successful response? It should be a hello. And there it is. We are getting our hello message successfully. Awesome, right? So now we are able to use the authentication service to get a token and use that token to authenticate. So let's see the logs, right? So let's see how this actually impacts the logs. So remember, I asked you to create 3 terminals, right? Go to your third terminal and run kubectl logs -f monolith. So the format is kubectl logs space pod name, where monolith is our pod name. -f is to enable streaming on these logs. So if I did it without streaming, if I do kubectl logs monolith, it'll just give me the logs. If I do -f, it'll give me streaming. So now while these logs are streaming, let's interact with, let's send some curl requests and see how it impacts the logs, okay? So let's send a curl request here. An additional log entry has been generated. Let's curl it in an insecure manner without using the token and see if we get a log there. Oops, sorry. It's the wrong port, sorry. 1080. And you can see here that as a result of these curl commands, logs are getting generated in the pod. Right? You can see these. So you can see which ones are going to the secure endpoint, which ones are going to the login endpoint, which requests are going to the default endpoint. And this is by far the best way to troubleshoot or debug any pod or application issue in Kubernetes. The very first thing that I do, and I think most DevOps engineers would do, is you check the pod logs. And how do you do that? Running kubectl logs. So kubectl logs space followed by the pod name. Very important command, very essential. If you're working on a Kubernetes environment, GKE or otherwise, that command is going to be absolutely essential. Okay. So now the next thing that we're going to do is we're going to test internet connectivity from within that pod. Right? So I want to make sure that once I'm within this monolith container, I should be able to access the public internet. Right? How else would I be able to, so if I wanted to download some dependencies or packages from the public internet, right? How would that happen without public internet access? So just to verify that, we're running a kubectl exec command. And now there are multiple ways to do this, but this is basically a command used to log into your monolith container. So basically this is saying, I want to log into my pod called monolith. I want to log into the specific container called monolith within that pod, and I want a /bin/sh interaction on that terminal, right? So I want a shell terminal. I don't want a bash terminal essentially, right? And now you can see if I do ls, I am now logged in to my pod. There are different ways you can run that same login in method. You can do kubectl-exec space IT space pod name, and then do /bin/bash, right? Even this will work, right? You have multiple ways of logging into the pod, basically. But now that we're logging into the pod, let's ping google.com and see if we're getting some responses. We are getting responses, so now I know I do have access to the internet. No issue there. But this was mostly just to show you how do you log into the pod, right? And once I'm logged into the pod, I can pretty much do anything I want, right? But again, ideally, you do not want to be making changes within the pod itself because pods are generally ephemeral in nature, or they are temporary in nature, okay? And that covers our session on pods. At this point, I'm going to pause a bit. I'll wait a minute or so. Let's see if anyone has any questions. This is the best time to ask the questions in these kind of intermediary stages while we're waiting. But I hope this concept is very clear to you, right? What is a pod? How do you use the pod? How do you deploy the pod? How do you describe Kubernetes resources? What kind of data you see once you describe it? How do you actually get logs from a pod? How we can use those logs to actually troubleshoot and debug certain scenarios. As well as we also learned how to actually log into a pod using this exec command, right? How to log into the pod and get access to the shell terminal. Okay, and now let's get on to services, okay? And this is the best way to explain the services, right? Exactly how they've written it here. Pods are not meant to be persistent. They can be stopped or started for many reasons, right? It could be anything like the node might die, a failed liveness probe, failed readiness probe, lots of things. They aren't meant to persist over long durations of time. But what happens if you want to communicate with a set of pods, right? Say a pod gets restarted, it gets terminated and gets recreated. It's going to get recreated with a different IP address every time. How will we know which IP to communicate? How will we know how to communicate with these pods, right? And even in the scenario where we want to expose these pods to the external world, to public internet, right? How do we do that? And that's where services comes in. Services is perhaps, it's also one of the most essential resources in Kubernetes. It provides a persistent endpoint for pods. So your service basically has a bunch of pods in its backend. So instead of communicating with the pod directly, what you will do is you will communicate with the service. The service will, on your behalf, the service will send requests to any pod, right? It's not going to go to a specific IP that you're looking for. It's going to say, okay, I am serving traffic to XYZ pods. You have sent a request, so I'm going to forward that request you sent to any pod which is healthy and which is capable of receiving your request. Now, how does the service know which all pods to serve traffic to? And that is a very important question. The service knows which pods to serve traffic to by using something called labels, Kubernetes labels. Very important point. I'm going to repeat it again. A service knows which pods to send traffic to by using labels. So if a pod and a service both have similar labels or the same labels that match, the exact same labels that match, only then will the server say, okay, this pod is my backend. So if I get a request, I'm going to send it to this pod, which has the same label as I do. Okay, very important. Now, there are different types of services itself, right? Depending on the extent to which we want to expose our pod or our deployment, we can have different types of services. So in a sense, there are three types of services. There is a cluster IP service, there is a node port service, and there is a load balancer service. Okay. Cluster IP service is the default service which gets created. If you create a service and you don't mention that I want it to be cluster IP, you don't mention I want it to be node port, and you don't mention I want it to be load balancer, by default it's going to pick up of the type cluster IP. This kind of service is an internal service, meaning it's only accessible within the cluster. Node port service, on the other hand, it gives each and every node in our GKE environment a public externally accessible IP. So basically, it exposes your pods via the node's public IP. So for example, in our case, in our Nginx case, right, we exposed the service using load balancer, if you remember. Earlier on, we got a service called, let me just leave the shell. If I do kubectl get svc, you can see that I created a service type load balancer, and my external IP was given here. If I created this as a node port type, what would happen is I would not get an external IP here. Rather, this external IP becomes the external IP of each and every one of my nodes. So every node, if I go to my compute engine, essentially, all the node public IPs become my service endpoints. So if I open this IP on the browser, it will take me to Monolith Application. If I open this IP, it will take me to Monolith. If I open this IP, it will take me to Monolith. So instead of having a single endpoint, like we did with the load balancer, in this case, our endpoints become the public IP of the nodes, which is not ideal, right? There are very few circumstances in which you want to use node port, right? In general, in a proper Kubernetes environment, you will mostly find people using cluster IP and load balancer. There are certain scenarios which you will be using node port for, but majority of the times you'll be working with the first and third services. So now we're going to learn how to create the service and use label selectors to expose pods to that service. So let's get back to the directory and let's open a different pod YAML file. So previously we were working with monolith.yaml. Now we're going to be working with secure monolith.yaml. So let's output it and see what it is. So it's very similar to the original Monolith application. You can see, in a sense, it's same, but there are a lot of notable differences. Okay, firstly, you can see that I have two containers. Previously, I just had my one. If you remember, I just had this container image before, but now I have two containers. I have an Nginx container as well as my Monolith application. So I have a front end and a back end. I'm mounting some volumes over this and passing my SSL secrets here. I am defining liveness probes, readiness probes. I'm defining what all volumes or disks I want to be mounted to this. And I'm also mentioning what configuration parameters I'm passing here. But I know it's going to be a little complicated. I don't expect you all to understand this entire YAML file in one go. But this is a good example you can use, right? This pod file. So we don't use pods much. We mostly use deployments. But from here till here, this is actually very similar to what a production setup might look like. It has a lot of the best practices, right? We're defining resource requests. We're giving liveness probes, readiness probes. We're giving volume mounts, config maps. It has everything that we need for a proper production application. So it's truly a secure monolith, right? It's a good one. So let's work with this for a while. So the first thing we're going to do is we're going to create a Kubernetes secret. And I'm not going to go too much into detail into this, but basically, we have some SSL certs, okay? It's in this TLS folder. So if I just do, I can see that I have my certificate files here. I want to put these certificate files in the form of an encoded secret, right? A Kubernetes secret. And that secret is going to be utilized by my application. So every time the application needs to do SSL validation, it's going to pull data from the secret and validate it. So first, let's create the let's create the secret first. So I'm running kubectl create secret command, and I'm creating an opaque secret called tls-search from the file which is tls-search. And if I do kubectl get secret, I will now see my secret is here. It's been created. It's an opaque secret. Remember the describe command? Let's use that, right? If you're kind of confused about what the secret is, let's get some more information on it using the describe command. So kubectl describe tls-search. And now I can see it's been given a name. It's in the default namespace. It has no labels. And I can see the data, right? It has the certificate file, and it shows the value here. You can also run an edit command to actually see these values, but it's encoded and encrypted, right? So now we have our secret file. The reason why we're creating the secret before our pod itself, so if you look at the secure monolith pod itself, right, you'll notice that if I just run the create command on this, it's going to give me an error. Why will it give me an error? Because there are certain dependencies which it doesn't have. So for example, this secret, TLS-search, it needs to exist for this to work. A config map called nginx proxy conf, this needs to exist for this pod to get deployed successfully, right? So before we actually create the pod, we have to create the secret and the config map. So when we created the secret, let's go ahead and create a config map. Now, what is a config map? Config map is a very, very, very useful resource. So let's take a look at this nginx proxy file. Okay. So this is our nginx configuration file, very standard. Okay, and a lot of nginx images will have a configuration file like this. But say I want to modify this configuration, right? Say I want to change something over here. I want to add some rewrite or something like that. Normally, how would I have to do it? I would have to build the image again, right? I'd have to make that change and build the image from scratch, and then deploy the image as a pod, and then my new pod will have the right configuration value. That's a lot of effort just to change a few sentences, right, in a configuration file. So the simpler way to do that is to pass these changes via a config map. So now we have a config map. And if I do a describe on the config map, you can do CM as a short form for config map. So kubectl describe CM nginx proxy conf. And I can see the data within this, right? So it's basically passing on this file to nginx proxy.conf. So now if I want to change a value, I don't have to recreate the image. I don't have to recreate the pod, nothing. All I have to do is modify the config map itself. I will edit the config map, change these values, and then recreate the config map or apply the config map changes, and that's it. It's done. I have changed the configuration without touching the pod itself. And this is very useful when you're working with, Nginx containers, Apache containers, MySQL containers, anything which has a dynamically changeable configuration file. Config maps are amazing there. So we've created our config map, and I'm going to pick up the pace a little bit. I think we're lagging behind a bit, but so we've created the config map. Now let's create the pod. So we have our secret, we have our config map. All the dependencies are met. Let's go ahead and create the pod. So I ran kubectl create -f pod / this time we're creating the secure monolith one. So now if I do kubectl get pods, you can see it's creating. You'll notice here that here it says 1 out of 1, 1 out of 1. It says 0 out of 2. What does the 0 out of 2 stand for? It stands for containers. So if you noticed in this YAML file, right, it has two containers. It has an Nginx container and a monolith container, which is why this is running too. So this secure monolith, right, is essentially a compilation of these two pods in a sense. That's one way to think about it. And if you wait a bit, eventually your container will reach the running status and it will be active. So now that we have our pod ready, let's expose this pod, okay? So let's take a look at the service file here. So here we are exposing this monolith file as a type node port. And we're mentioning the node port number also as 31K. This means that essentially my monolith service is going to be exposed on all of my node public IPs over port 31K. So if I go to my compute engine here, after creating the service, if I go to my compute engine, if I pick up any of these Kubernetes nodes public IP and I curl it, if I do curl, didn't I copy it? So if I do curl public IP over port 31K, I should get access to the Monolith Port, right? Right now it won't show me anything because I haven't done it, but let's create this, okay? So I have my service. So kubectl create -f services monolith.yaml. Let's run get svc. Here you can see that a node port type service has been created. And here it doesn't get provisioned an external IP. Why? It already has this external IP. It's using these external IPs. So now, if I run that same curl command, oh yeah, it won't work. I explained that a little bit. Okay. So now that we've deployed this, okay. So let's get a better look at this service. Actually, I think I might have rushed that a bit. Let me take a better look at the service. Okay. It's called Monolith. So everyone please pay attention at this part. Okay, so this part is important. I'm going to ask you guys a question here. Okay. /monolith secure monolith. I'm going to open these two folders side by side. So I have my service file for my secure monolith, and I have my actual pod file for my secure monolith. Okay. Now let's take a very close look. If you remember, I told you, how does the service know that I need to send traffic to a particular pod? The service knows that by using certain selectors which are matched to certain labels. So in my service, I have a selector. So it says for any pod which has this label app equals to monolith and not or and it has a label secure equals to enabled, those are the pods I will serve traffic to. But if I look at my pod YAML itself, if I look at my label, it has one label, app equals to monolith. This second label, secure equals to enabled, is missing. Because that second label is missing, this service, even though it's created, it doesn't know it has to serve traffic to this pod, which is why when I'm curling that public IP, the service is receiving the request. It just doesn't know which pod to send the packet to, because there is no pod which has the right labels. So let's modify this, right? So what if there are different ways we can modify this. For the sake of this demo, let's go to our pod file. You can use any text editor. I'm going to use V. I'm going to go to monolith.yaml. So we're working on secure monolith. So open up secure monolith.yaml file using any text editor. Okay, I'm using V for my preference. And here, we're going to add another label, which was secure equals to enabled. Please verify your spelling and double check that the spelling is correct. Otherwise, it won't work, right? So now I've added secure equals to enabled. Previously, that wasn't there. So now if I do kubectl so what I did was I ran kubectl apply -f on that same file just to make sure that the changes get rolled out. And let me do kubectl. So now just to verify that it has the right labels, let's run a describe on secure monolith pod. I'm sorry. The syntax is describe pod, secure monolith. And here I can see that the label has been updated. So now it has the secure equals to enable label. What does this mean? That this means that now our service has a pod to send traffic to. So that same curl command, let's try it again, right? I think what is the port again? The port is 31K, right? Let me see the service. Yeah, the node port is 31,000. So let's pick up any external IP. I'm taking the first one. I'm going to curl this over port 31K. And now what I should see is that I should be getting the response. Did I miss out something? Okay, just a second, let me see. So we created our node port service. We updated the, we created the monolith service, we created the pod. Let's take this, since these two have been done. I'm not getting a response from this. I'm going to just double check. I might have made a spelling mistake somewhere, but we'll quickly go through that again. Ah, I see. Okay. So the reason that was not working is because I missed a step, which is create firewall rules. So basically, before you run this curl command, these nodes which you've created, right? We need to use firewall rules to basically allow them to receive traffic from the internet. Right now, there is no firewall rule which is allowing them to receive traffic. So even if I send it a request, it's not going to receive a request. So what I'm going to do is I'm going to create a firewall rule called using this command, gcloud compute firewall rules create, which you'll find over here. And what this command does is it creates a firewall rule, which says, the firewall rule itself is called allow monolith node port. And it says, in a sense, that allow public internet, meaning 0.0.0/0, meaning anyone from the internet that wants to access my GKE nodes over port 31,000 will be allowed. And now that I have this firewall rule backing me up, now let me try this curl command, right? As you can see, I am getting a response now. That's exactly what I wanted. So you can run this. I can even open it on, so I can pick up any of my nodes. Where is it? Sorry. So it's not just this first node IP, right? So let's take the second node IP. Oh, let's open it on the browser. Oh, sorry. It's HTTPS. Why did I get a response for this one here? Curl. Yeah, so I'm getting my hello response here. Oh, sorry, because the front end is not okay. So the reason that's not showing up on the browser is because we don't have a front end yet. We just have our back end. So if we curl it over port 443, right now we've configured our application to. Remember, this is a secure monolith application. We cannot access it over normal HTTP. We have to access it over HTTPS using our SSL. If you remember, we created a secret for our SSL termination. This is why. So now we're able to access it. And you see that I put in the first node value, right? So let me just show you that I can take any node value. Because when I expose it as a node port, all of my GK nodes become kind of like load balancers. I mean, it's not a good way to put it, but they become like public endpoints which I can access my service through. Again, this is not the ideal scenario. Why? Because you have 3 public endpoints here, right? Now your service is accessible over here, and over here. And SSL termination is happening at the pod level instead of at the load balancer level. Right? So these are not ideal scenarios, but this is one way of doing things, right? The ideal way of doing things, how I would do it, is I would keep everything under a single load balancer. But you should also understand what is the purpose of a node port, right? So that's where all of this comes into play. By the way, so there are other ways of adding. So remember how I changed the label on that pod, right? There are simpler ways of doing that as well. You can just run the kubectl label command. So just running kubectl label pods,
I think we've just lost Alfred from the call. Let me just try reaching out to him.
Hello, Sarang, can you hear me?
Yeah, I think you're back.
How long was I gone? Like I know I had some network issues, but I just realized it.
Just 10-15 seconds, I believe. Not
Oh,
more
okay. Thank God.
Last 10 minutes.
So I hope I was not like rambling to an empty audience, right?
No, definitely.
Do you know what was the last thing I covered? I think I was covering the labels, right? How you can add labels through this command, or I might have missed that out. Yeah, I think this is the last thing.
Yeah, I think you covered that. If someone from the audience can confirm whether that was the last part they heard, but yeah, it was just last. Okay, perfect.
Okay, awesome. Thanks. Apologies for the inconvenience. I don't think that should happen again. But yeah, let's proceed. I hope none of you missed out on too much, right? And I think we have 20 minutes to spare, so let's get going. So as I said, in my example, how I changed it was I went to the actual. Oh, I need to reconnect now since I've changed this one. I need to open a new Cloud shell. So previously what I did was I had gone to my service YAML file and my pod YAML file, and I had manually modified these labels, right? I added secure equals to enable using my text editor. But the alternative is if you just want to add a label directly, you can run kubectl label resource type. This can be pod or deployment, followed by the resource name and the label type, right? A very simple way of adding it. Now, I want to show you the output of this command, kubectl describe services monolith grep endpoints. What this command will do actually is it will show me all of the endpoints my service is sending traffic to. So all of my pod endpoints will get listed over here. Let's open this in new area. There we go. My sessions have been there. Okay. So if I do kubectl describe and I describe my service, which is the node port service, I can see my endpoints. And right now my endpoint is 10.0.1.3, port 443. What is this endpoint actually? What exactly is this endpoint? This is my pod IP. So if I go to secure monolith and I do describe, kubectl describe pod, here I can see that same IP 10.0.1.3, I believe it was. Yeah, 10.0.1.3, the same IP is my pod IP. And right now I just have one pod. So if I had two pods, if I had two of these pods, right now I just have one pod of secure monolith. But if I have two of these pods, then what I would see here is that instead of just one endpoint, I would have two endpoints, the second endpoint being the second pod. Right, and now they're doing the same thing, right? They're taking out the node public IP. So you can take out any node public IP and you can curl it, you will get your response. And that's how you actually use the node ports.
Alfred, there's a question in the chat room. So did applying the configuration changes to the pods restart the pods?
No.
Does that
happen? Very good question. Whoever asked that, very good question. If you remember, I ran the kubectl apply command, okay? Now, there are two scenarios. There are two potential scenarios. In one scenario, the pod is going to get restarted. In the second scenario, the pod will not get restarted. In this case, what is the change I made? The change I made was only to the metadata. I made a change to the labels or the annotations or something like that. With these kind of metadata-ish kind of changes, if you run an apply command, it's going to be applied without any pod restart. But say instead of changing the metadata, say if I changed the port number, or say if I changed the image name, right? Right now it's giving a particular, it's using a particular image. If I went to that same pod file, that pod/monolith, if I go here and I change this image type, or I change any of these things within the specification, then my pod is going to get restarted. But if you notice, what I changed was something in the metadata, in the labels. Because I changed something in the labels or the metadata, the pod did not have to get restarted. The metadata got updated on the fly. But if I'm making a change to the actual specification of the pod or the actual containers, then the pod is going to get restarted. So if you look at the pod, let's look at the time duration, right? It's been there for 16 minutes. It did not get restarted. After I changed the label, it did not get restarted. A good question, whoever asked that. Yeah. And now let's move on to the final thing, right, which is deployment. So right now we've been working with this monolith up to now, but from now here on out we're going to be using microservices. We're going to use a separate microservice for auth. We're going to use a separate microservice for hello, and we're going to use an Nginx front end. Okay. So what is a deployment? A deployment, I would say, it's a declarative way of defining a set of pods. Okay, so you can consider deployments as a group of homogeneous pods. Homogeneous meaning they're all the same type of pods, right? The exact same pods. A deployment declares certain things to Kubernetes. It declares to Kubernetes what the desired state is. So in my deployment file, I'll have a parameter called replicas. Okay. So in my deployment file, I have a label called app equals to hello, and my replicas equals to 3. This means that every pod which is part of my deployment, every single pod which is part of this deployment will get this label automatically. This app equals to hello label will automatically apply to every pod which is part of this deployment. Similarly, this deployment should have 3 replicas or 3 pods. So here you can see I'm declaring to Kubernetes that I want 3 pods, and you can see that node 1, node 2, 3, node 3. 3 nodes, and the pods are spread out across these 3 nodes, right? And remember, my deployment is using a replica set to tell Kubernetes that this pod should have 3 replicas, right? It should have a desired value of 3 pods. Now, what happens, say, if node 3 goes down? Okay, if this node goes down, now this pod also will get terminated because the pod is contained within the node. Because the pod gets terminated and the node gets terminated, now what happens to that third pod? Because in our deployment file, the deployment file clearly says, I need to have 3 replicas. Kubernetes knows that the desired state is 3 replicas. But because of this event, because of this node termination event, we are now stuck with 2 replicas. Kubernetes will realize this because there is a deployment that defines our desired state as 3 replicas. Kubernetes is going to use this information. It's going to realize there is a difference between the current state and the desired state. What is the difference? The difference is mainly 1 pod, 1 replica. So to fill the gap between the desired state and the current state, Kubernetes will create a new pod. The new pod, because it doesn't have space to be provisioned on a third node, which it doesn't exist, the third node doesn't exist anymore. It's going to get provisioned on any of the other 2 nodes. And this is why deployments are so important. This is why I don't even remember the last time I used a standalone pod. You have to use pods with deployments. Why? Because if your pod gets terminated, remember we told you pods are ephemeral in nature. They're not meant to last that long. If you create a pod, right now my secure monolith file, if I do secure monolith, if I delete secure monolith, it's gone. If the node in which secure monolith is contained, it gets deleted, it's gone, that pod is gone. But if I kept that pod as part of a deployment and I define my desired state as 1 replica, then no matter how many nodes goes down, as long as there's 1 node, there will be at least 1 replica of this particular pod, which is why deployments are very important. Okay, so now we're going to go and work on actually creating these deployments using the deployment files. So let's look at, right now we're going to work with microservices. We're going to use the authentication microservice, the hello microservice, and our front-end microservice, which is nothing but an Nginx microservice. So let's look at our auth.yaml deployment file. The first difference
there are a couple of questions. Do we take them later, or is it there's room for now? Because I see the time clock is running.
I'll cover them soon. Like we're almost done, right? I'll cover them.
Yeah, sure. Let's take them.
But are the questions pertaining to something which we're doing right now?
So it's around pods and node pods.
Okay, I'll cover it then in a bit.
Yeah.
Okay. So if you look at our actual deployment file now, it's a little different from our pod YAML. Firstly, the most important difference is the kind equals to deployment here. It's no longer kind equals to pod. And now I have 2 specifications. You see, previously I just had spec containers in my pod, but now I have 2. So from the first spec till here, this is for the deployment. Here I'm defining things for my deployment. I want every pod in my deployment to have this selector, to have these replicas. So I'm mentioning we should have one pod, one replica, should have these labels, so on and so forth. And here, the second spec, this is where I actually define my containers and this is where I define my pod actually. I can add containers and stuff to the pod. So it's like a declarative way of defining my pod. So let's go ahead and create this deployment. And now if I do kubectl get deploy or get deployments, I will see my authentication deployment is there. Soon it will be ready. So now my deployment is there. Let's expose this authentication file. And now you'll notice that, let me just create this, okay? So if I look at the service auth.yaml file, it says service, but it doesn't mention type equals to node port or cluster IP or load balancer. So what type of service is going to get created? By default, it's going to create a cluster IP service, which is good, because our authentication service needs to be internally accessed. Okay, our front end should be publicly accessible, but the backend which is hello and auth, these two backends should be only privately accessible. So just like I deployed my auth.yaml, I'm deploying my hello.yaml as well. And now if I look at my get deploy, I'll have my authentication deployment, which has one replica, and I have my hello deployment, which has 3 replicas. And if I do my service, I have my hello service, which is also cluster IP, which is good, because like I told you, hello and auth, these two are backend services. They do not need to be publicly accessible. The front end, which is Nginx, should be publicly accessible, and Nginx should have access to auth and hello. But the user itself should not have direct access to auth and hello. And if let me quickly show you the hello deployment file. Here you can see I'm defining my replicas equals to 3. Because I'm I'm defining my replicas equals to 3, I can see in my kubectl get pods, I have 3 pods of my hello deployment, each with a randomized suffix. Okay. And now finally, before we're going to deploy the Nginx front, so we've deployed our backends. Only thing left is my Nginx front end. So like I said, before I deploy my Nginx front end, I will need the config map. I hope you remember what a config map is. It's for dynamically changing Nginx proxy configuration or any configuration file within a pod without having to recreate the pod or recreate the image. And it is a dependency, so we need to create the config map first before we create the deployment and before we create the service. Deployment is created, and let's create the service. Now let's take a look at the service, okay? So both the other services, the service for auth and hello, were both cluster IP. But now we're creating a service for our front end. Our front end needs to be publicly accessible by the internet, which is why we're creating this service of type load balancer. And we're exposing it over port 443, which is because it's secure, right? We're securing it with SSL. So any user that wants to access our application will have to access it via this load balancer public IP. So now if I do kubectl get service, you can see for my front end, an external IP is being provisioned. And that's pretty much it, right? So now what's going to happen is, eventually I will get a public IP on this, which I have here. And now I can just curl, and I get my response, right? Now I even have an Nginx front end, so I can do this. Oh, sorry, let's do this. So now I can just open this on my browser, and it'll give me hello, right? Because now I have the Nginx front end as well. This is exactly how you want. This is exactly how a microservice architecture will look like, right? Let me show you a very quick diagram. It's very important that you understand how these services are interacting with each other. So we have my auth service, we have my auth, which is private, and I have my hello. These are both private. And I have my Nginx. Now, all of these are part of the same cluster. So if this can talk to this, Nginx can talk to this, and Nginx can talk to hello. Why? Because both of these are cluster IPs. These are accessible internally. But you as the public user or anyone from the internet, if I want to access auth or if I want to access hello, I cannot access either of these directly. I will have to go via Nginx. So there is no direct communication with these backends. This connection won't happen, and this connection won't happen. Okay. And this is very essential. This is what a microservice architecture generally looks like. You'll have a bunch of microservices in the backends. You'll have certain public-facing microservices and majority backend-facing microservices. And the backend microservices can interact with each other over cluster IP. The front end will interact with using load balancer type or node port if you're very experimental, but generally cluster IP. But let me show you one thing, right? So if you remember, I had 3 replicas of my hello pod, okay? Because I've split this into microservices, let's understand some of the benefits, okay? I have 3 replicas of hello and 1 replica of auth. In my previous scenario, in my secure monolith scenario or my monolith scenario, if I wanted to scale up just hello, say I'm receiving a lot of traffic in my hello service, but my auth service is not very active. But because of the nature of the monolith, I will have to scale up the entire application. I will have to scale up the entire monolith, including the authentication service, even though it's just the hello, which requires additional resources. This leads to underutilization and over-provisioning of resources. Very bad, right? It's a common drawback of monolith systems. But with a microservice-based architecture, I can independently scale these applications. So as you can see, authentication has 1 replica, hello has 3 replicas. What happens if I delete a replica? So I'm going to delete 1 pod. I'm saying kubectl delete pod, kubectl delete pod, and I'm giving the pod name. So I'm telling kubectl to delete this first pod. Now, can anyone guess what's going to happen next? Right? Should we be left with 2 pods? Should we be left with 0 pods? Should we be left with 4 pods, or should we come back to 3 pods? And what you'll observe is that if you remember, our deployment said 3 replicas. Kubernetes has realized, it has already realized there's a difference. The moment I click delete, it realized there's a difference between the desired state, which was 3 replicas, and the actual state, which is 2 replicas. To fix that gap, it created another pod. You can see this is a newly created pod, 14 seconds. And you see we are back to 3 replicas, exactly how the deployment file mentioned it. Very important. And I think the lab is almost over. One last thing I want to show you, right? We've mostly been interacting with the command line, which is good, which is how I always use kubectl commands, and I want you guys to learn that as well. But to be honest, on GKE, it's actually very chill. You can actually just use the UI. So if I click on workloads, this shows me all my pods and deployments. You can see deployments, pods. And instead of, so if I wanted to, so this hello deployment, right? Say I wanted to scale this up. So I can just click on actions, and I can click on auto scale. And I can choose minimum number of replicas, maximum number of replicas, and this will actually create an HPA for us. And HPA is a horizontal pod autoscaler. It's also a Kubernetes resource. And you can actually just create the full HPA instead of writing YAML. You can create it using this UI. You can also define autoscaling metrics for this. And just like you can define autoscale, you can also manually scale it. Currently as 3, I can choose 4. I think my time is almost out. Yeah, this is trying to shut down. But yeah, you can scale up this deployment. You can even expose it. So instead of manually creating my service YAML that you saw, I can just click on this expose button. I can choose which port I want to map to. So the target port, which is a container port, is 80. I can receive traffic over port 80. Service type, I can choose. I can add multiple port mappings also. I can choose my service type, cluster IP, node port, or load balancer. Choose load balancer, and then expose it, and that's it. It gets created. It's actually that simple. I don't even need to write any YAML. I can actually do almost everything I can do from this console UI itself. If I go to my services.ingress file, right, instead of running kubectl edit commands or changing the manifest files, I can even go to these YAML components and modify them. So if I go to edit, and I go to YAML, you can see I actually have access to the YAML file here, and I can make modifications here. This is actually very insane, right? You can do this entire thing from the UI. In your configuration, you even get to see your secrets and stuff like that. You can see all the different config maps and secrets that were created. Very useful. And it's a very simple way of doing things also. But with that being said, that actually concludes our final task. So click check my progress, and we should be done. I hope all of you have been able to reach the stage, right? Where we started with a monolith, we were working with that monolith all this while. It had a hello and authentication service. And then we were working with pods and services. And finally, we got to deployments, which is the best way of dealing with pods. And then we used deployments for our authentication microservice. We used deployment for our hello microservice. We used a load balancer service for our front-end Nginx, right? I think we covered quite a bit, right? These are the foundational basics of Kubernetes. These are the most important resources that you use in Kubernetes.